So this will be hopefully a really quick introduction to series and sums, which we deal with in 13.3. At least is enough of an intro to let us get a bunch of problems done in class tomorrow before we move on Monday. Here are the two formulas for today, the sum of an arithmetic series and the sum of a geometric series. The definition of series is basically just the summation of terms of a sequence, so they're pretty related. The notation is all the same. The t sub n here is usually going to mean the last term in most cases when we're finding the sum of an arithmetic series. Other than that, S stands for sum here, but the RT1 is still the same as the old formulas that we did. These first two examples are very basic, should go pretty quickly. The first says find the sum of the first 100 terms of the series, which starts as 3 plus 9 plus 27 plus 81. We can recognize right away that this is a geometric series, and we know that R equals 3. So if we take our geometric sum formula, which is T1 times 1 minus R to the n over 1 minus R, that's what we want to plug into. So T sub 1, just like it's always been, is our first term. We do 1 minus R is still 3. Our n here is 100. If we take the sum of the first 100 terms of this, we know that's going to be a pretty big number. Then we have 1 minus 3 on the bottom. After that, you just go straight to your calculator and you end up, as predicted, a huge number. 7.73 times 10 to the 47th, the decimal in there. So the geometric formula is pretty straightforward. The arithmetic one we do on the next slide has one extra step, so we'll take a look at that now. We can recognize that this series right away is arithmetic, so we know we're dealing with that. Sorry about that. So this is arithmetic. We know our d equals 4. So to use our arithmetic sum formula, that's n times t1 plus tn, and that's all over 2. So right away, we don't know the number of terms, and that's what we're going to need to come back to and try to find. So we'll be missing that. We know t sub 1 is our first term, which is 2. As I mentioned on the formula page, the last term in this case is 174. We take a look at these term numbers. We have 1, 2, 3, 4, obviously. If we can find the number of that term, we know the number of terms in the sequence, and that's what we did in the class before today's. We're going to divide all of that by 2. We need to go back and use the explicit formula in order to plug in and figure out which term 174 is. If I use my shortcut, I know that's negative 2 plus 4n is the formula for that. So if I set that equal to 174 and solve for n, I find out that it's my 44th term, which means I can get rid of this. And I know that this needs to be 144 in here. And then we found everything we need. So again, very straightforward. It was just one extra step from the geometric. And your final answer here is going to end up being 3,872 is the sum. This is a problem a lot like what we did yesterday in class, except now instead of, sorry, I did that again. Instead of trying to find the number of 4-digit numbers divisible by 3, we're trying to find the sum of all of those numbers. We talked yesterday that any number is divisible by anything, or multiples of numbers form an arithmetic sequence. So we know eventually we're looking to plug into this formula, the arithmetic series. So what do we know? We know that the first term, we can figure that out the same way we did. So we want the sum of that. We're not sure what that is. We don't know how many there are. We're going to have to go back and find that. But we do know that the first term is going to be 1,002. And we can guess and check and see the last one is going to be 9,999. 3 has a nice easy multiplicity rule, so that should be pretty easy to figure out. And that's going to be solved over 2. In order to find that out, we can plug into, if I use the shortcut, I can set 9999 equal to 999 plus 3n. So this here is the formula for 4-digit numbers divisible by 3. That's the explicit formula that will allow you to find that. That gives us that n equals 3,000. So again, I can erase this n now because I now know what it is and put in that that's 3,000. And then to get, so the sum of the first 3,000 terms, we end up with 16,501,500. So again, pretty similar to what we did yesterday, except we're just plugging into a different sum formula, but we'll see some of those problems in this section as well. So this last problem says you just get a job that pays $38,000 a year, but you're guaranteed a raise of $3,000 per year. It says how long until you've earned a total of $2,704,000. So again, it's a total. That's what cues you to use the sum formulas. So we want to know when the sum equals 2.7 million-ish. What we can tell right away, since the guaranteed raise is $3,000, we'll be adding $3,000 on. We know this is an arithmetic sequence. So we can use the arithmetic sum formula to start, and we know that sum is going to have to equal 2704000. What we don't know is how many years that's going to take. That's what we're being asked. We do know T sub 1, that's going to be 38,000. The other thing we're missing is T sub n here, and T sub n in words really means how much you make during the year that gets you to this total of $2.7 million. We're going to divide that by 2. So with one equation and 2 missing variables, that should be a clue to you that you need another equation so that you can solve a system. So if we go back to the explicit arithmetic formula, we can plug in, or we can just use our shortcut, and we end up with 35,000, which would have been what you made the year before you started. And that's going to be plus 3,000n, because that's our difference for each year. So what we can do now is a simple substitution, really easy system. That can come into this place. We'll do this fairly quickly, but what we end up with is that 2704000 now equals n times, and when I substitute and simplify, I get 73,000 plus 3,000n all over 2. Again, I'm running out of room, so I'm going to skip a little bit of the algebra. But when you simplify that, you get 3,000n squared plus 73,000n minus 5,408,000. That's going to equal 0, so I want to solve that quadratic. First thing I would do is divide by 1,000. You have a couple options here. You can plug this in the quadratic formula. I prefer graphing and calculating through there, but either way, you're going to end up with n equals 32, which works out nicely. So after 32 years, you've made a total of $2,704,000, which is a little depressing since Tom Brady makes about a third of that in a year, and he took a pay cut, and it's going to take you 32 years to get there. But what can you do?